Hi guys, and welcome to graphing any rational equation where m is less than n. So we started this example in a previous example where we found its x-intercepts, vertical asymptotes, and horizontal asymptote. So feel free to go back there and check those out. And we're just going to start right from where we are here. So let's go ahead and put these on our graph. So the x-intercept is the origin right here. So we're going to put a nice blue point right there for that. The vertical asymptotes, this time we have two of them. We have both at +3 and at -3. So that means we're going to have a vertical line both at x equals -3 right here. And again, we're just going to dot it because it's not quite on our graph. It's not actually on our graph, but it's going to help guide us. Okay, and then also here at x equals +3. Nice right on up there and down there. And so those are our vertical asymptotes. And then the horizontal asymptote, whenever m is less than n, remember it's y equals 0, which is just the x-axis. So we're going to put that nice little horizontal asymptote right along there. Alright, so now what we're going to do is we're actually going to plug in these values. And I've actually already done that for you. And so when I plug them in, so if I plug -4 into here, I'm going to get 20 divided by 7, which is going to give you a nice big decimal, and you just want to round those. And about to 1 decimal point is good, and so this gives you about 2.9. Okay, when you plug these in, -5 will give you 1.6, and -6 will give you 1.1. So you're going to come over here, you're going to go ahead and graph those. So we've got -4, 2.9, which is about 3. We've got -5, 1.6, which is about 1.5. And then -6, 1.1, which is about 1. Okay, and then just go ahead and draw on your curve now, where you're connecting with a nice smooth curve, and at the ends, you're approaching that asymptote without actually touching it yet. Okay, so you've got that nice branch right there. And then let's go ahead and do the values to the right, because this is going to have a really nice symmetry with those values to the left. Okay, it's actually going to end up being the same things except for negative. So when we plug in +4, we're going to end up with -2.9. Plug in +5, end up with -1.6. And then finally, same thing, when we plug in +6, we end up with -1.1. So let's go ahead and plot these as well. So we would have +4, so -2.9 is almost at -3. +5, -1.6 is about 1.5. And then +6, 1.1 is going to get us just beyond that 1. And we can do the same thing. We can go ahead and draw on our curve here, where we're approaching those asymptotes at the end there without actually crossing them. Alright, so there we have the kind of the outsides of our graph there, and they have a nice symmetry where they're kind of pointed away from each other and look nicely reflected across there. Okay, so now let's go ahead and look at and see what's going on in the middle. So in the middle, we already have 1 point. We have that 0, 0, which we found from the x-intercept. And so we're going to just need to plot 2 more points. And I picked x equals -2 and x equals +2 because those 2 points just work out very nicely. So when x equals -2, when you plug it in, you end up with also y equals -2. And then the same thing, when you plug in +2, you're going to end up with y also equals +2. And so we come on over here and we can plot those. So -2, -2 is down here. +2, +2 is right there. Now, if you're like me, you're looking at this and you're thinking, oh dear, we're going to have to end up crossing that horizontal asymptote, which you said we weren't allowed to do. But I gave a very basic definition of asymptotes as lines that you're not allowed to cross. It's really at the end behavior. So in the middle of a graph, you're allowed to cross them. Okay, so when we do this, we're going to have just a nice smooth curve. Make sure you're not making a line, but a curve right up there. And then the other side is going to go right down here. And that will give us our final answer, where we have the 3 different sections of the graph, and it's okay for this graph to cross the horizontal asymptote in the middle as long as it's approaching and doesn't cross the vertical asymptotes at the end. And that's it.